Hello everyone. Now we have to discuss partial fractions and initial and final value theorems. Okay. So here I am providing one example. So based upon this, I will explain the concept of partial fractions. So in this, obtain the Laplace transformation of f of t, which is equal to 1 minus e power minus at, where a is nothing but constant. We all know that f of t is there. Then we have to calculate f of s, right? That is f of s, which is nothing but what? 0 to infinite f of t into e power minus st dt, right? From this, f of s is nothing but 0 to infinite. F of t is what? 1 minus e power minus at e power minus st dt. That's it. From this, f of s, which is nothing but 0 to infinite e power minus st dt minus 0 to infinite e power minus at e power minus st dt. So we all know that 0 to infinite e power minus st dt is nothing but 1 by s is nothing but unit step, right? Therefore f of s, we all know that already we did this, 1 by s minus this is what? 1 by s plus a. So from this, f of s, which is nothing but s plus a minus s by s into s plus a. Therefore f of s is nothing but a by s into s plus a. So like this we can do the analysis. So this is given f of t. This is the Laplace transformation of this function. Okay, next we will do this. A function in s domain is given by f of s 50 by s square plus 2s plus 2. Then we can calculate the inverse Laplace transformation. So for this, here I can provide the procedure of partial fraction. We can calculate by using that's it. We can use partial fraction method to calculate inverse Laplace transformation. Okay. So for this, first I would like to take f of s. F of s is what? 50 by s square plus 2s plus 2. Now f of s is nothing but, can I write s square plus 2s plus 1 plus 1. So obviously we can provide like this. So s square plus 2s plus 1 is nothing but what? S plus 1 whole square, right? Which is nothing but 50 by s plus 1 whole square plus 1. So f of s is what? 50 into 1 by s plus 1 whole square plus 1. We all know that the formula f of s is nothing but 1 by, already I have provided this formula in formula table. F of s plus a whole square plus 1 square or omega square, right? What we have? E power minus at, or you can write in place of 1, omega, e power minus at sin omega t. So this equation is looks like this, right? Therefore 1 by s plus 1 whole square plus 1 is nothing but what? Therefore f of t, which is equals to 50 is constant into e power, in place of a we are having 1, that's why it is minus t, in place of omega we are having 1, that's why e power minus t sin t. So like this we got inverse Laplace of this function. This is the inverse Laplace of this f of s. So by using partial fraction method we can calculate the inverse Laplace. Okay. Yeah, before that first I would like to explain initial value theorem, final value theorem. So what is this initial value theorem, sir? Simply it is what? Limit initial mean, right? Means instant of switching, that is when t tends to 0, that is time domain f of t, right? Is equals to limit s tends to infinite, we can write s into f of s. This is the formula for initial value theorem. Like that for final value theorem, limit final means what? That is final value, that is steady state value. When we have final value, let us say infinite, which is t greater than 0, f of t, which is equals to limit, now it is s tends to 0, s into f of s. Why we need this initial value theorem? It can provides the information regarding initial value. Why we need this final value theorem? It can provides the information regarding final value or steady state value. When we are having initial value, when t which is equals to 0 at the instant of switching, it is what? When t more than 0, that is at the instant of switching. This is, that is after some time of switching. That's it. This is about initial value theorem, this is about final value theorem. Now we can do one problem based upon this. So function in s domain is given by like this: s square plus 3s plus 1 by s into s square plus 3s plus 2. For this find f of t, that is we can calculate inverse Laplace. See, this is what f of t, and the steady state solution, that is we have to calculate the final value. Study when we are going to get steady state, that is final value, by using final value theorem. So we all know that we can get inverse Laplace by using what? By using partial fraction method, right? Therefore first I would like to get f of t. Therefore listen carefully, this is what s square plus 3s plus 1 by s into s square plus 3s plus 2. Clear? So for this f of s should be equals to, you can write s square plus 3s plus 1. This could be written like this, right? S plus 2 into s plus 1. Can we write like this? Therefore we can write f of s should be equals to, let us say this is, first we have to write 3s plus 1 square plus 3s plus 1 by s into s plus 2 into s plus 1. Can we write like this? Obviously we can write like this. Now it is p by s, q by s by 2 plus r by s plus 1, means some constant by this first term, like that some constant by this second term, like that some constant by this third term. That's like this we have to do the fractions. So p by some s value, q by this term, like that some constant by s plus 1. So this is the analysis of partial fractions. So now we have to get the values of p, q, r. That's it. Okay. So to get p, when we have p, simply this is what, s square plus 3s plus 1 by, to get p, which is p by s, right? Therefore there is no term of s in this equation. Simply we have what, s plus 2 into s plus 1 when s is equals to 0, because there is no term of s in this equation, right? Because s is present under this p by s. That's why s is equals to 0, which is equals to what? When s is equals to 0, we are having simply 1 by 2, right? 1 by 2, that's it. P is equals to 1 by 2, like that. Q by s plus 2. So now we have to get the value of q, that is s square plus 3s plus 1 by s into s plus 1 only. There is no term of s plus 2. Okay. To get q, which is nothing but what, s square plus 3s plus 1 into s plus 1 only when s is equals to minus 2, because s plus 2 is equals to 0, which is equals to what, s is equals to minus 2. At the value of minus 2 only we can get the value of q, right? Because q by s plus 2. That's why s plus 2 should be equals to 0. Okay. Simply to get the value of q when s is equals to minus 2, like that. To get the value of r when s is equals to minus 1, like that. To get the value of s when s is equals to 0. That is the procedure, right? When s is equals to 0, there is no term of s in this p, like that. To get q, there is no term of s plus 2 when s is equals to 0, which is equals to what, when s is equals to minus 2, we are having the value of q, which is equals to minus 1 by 2, like that. R should be equals to what, s square plus 3s plus 1 by, now it is s into s plus 2 when s is equals to minus 1. Clear? When s is equals to minus 1, we are having the value of r should be equals to 1. Therefore p, which is equals to what, 1 by 2, q, which is equals to minus 1 by 2, r, which is equals to 1. Therefore what we have, f of s, which is equals to what, p by s plus q by s plus 2 plus r by s plus 1. P is what, 1 by 2 by s minus 1 by 2 s plus I think s plus 2, right? S plus 2 this is plus 1 by s plus 1. That's it. We all know that some constant 1 by 2 by s is nothing but f of s. For this, what is the inverse Laplace transformation? See, we can apply inverse Laplace. Therefore, f of t, some constant by s is nothing but unit step, right? Therefore, 1 by 2 u of t minus, this is constant by 1 by s plus 2 is nothing but what? That is 1 by 2 is constant. 1 by s plus 2 is what? E power minus 2t, right? If you have any doubt, go through that formula table. Like that, plus 1 into e power minus t, or you can write f of t, which is equals to 1 by 2 minus e power 1 by 2 minus 2t plus e power minus t. So there is no representation of u of t. You can write like this or you can write like this. This is the inverse Laplace transformation of this equation, right? This is the way of partial fraction method. Okay, so from this we can calculate the steady state solution. We all know that steady state, to get steady state value or final value, we can use final value theorem, right? That is, what is the final value theorem? That is limit final, that's why limit t tends to infinite f of t, which is equals to limit s tends to 0 s into f of s. First, I would like to do the analysis with respect to limit t tends time domain analysis, or you can consider, you can calculate with respect to time domain analysis or frequency domain analysis. First, I would like to consider limit t tends to infinite f of t, right, which is equals to what? What is the value of f of t? We got this 1 by 2 minus 1 by 2 e power minus 2t plus e power minus t. That is limit t tends to infinite f of t 1 by 2 minus 1 by 2 e power minus 2t plus e power minus t, right? We all know that t tends to infinite. Obviously, e power minus infinite should be equals to what? 0, right? E power minus infinite is nothing but 0. That is 1 by 2 minus e power minus infinite by 2, like that, which is equals to 1 by 2. This is 0, this is 0. Therefore, limit t tends to infinite f of t is what we got? That is, we got 1 by 2 from this case 1. Now we have to verify this answer by using this s domain. From this time domain, we have the final value of 1 by 2. Now we have to verify this with respect to s domain. Let us consider that case as case 2. Okay, that is, now we have to consider limit s tends to 0 s into f of s. What is the given function? Given f of s is what? See, f of s is what? S square plus 3s plus 1, s square plus 3s plus 1 by s into s square plus 3s plus 2. This is f of s. Therefore, s into f of s is what? Which is equals to s square plus 3s plus 1 by s square plus 3s plus 2. That's it. Now, from this, limit s tends to 0 s into f of s is nothing but what? Limit s tends to 0 s square plus 3s plus 1 by 3s plus 2. Simply when we substitute the value of s is equals to 0, obviously we will get the value should be equals to 1 by 2, right? See, this is from time domain, sorry, frequency domain, and this is from frequency, this is from time domain. From both the cases we are having the value 1 by 2. Therefore, final or steady state value is what? 1 by 2. So like this we can solve, right? You can solve by using either time domain approach or frequency domain approach. Now we can get a function in S domain is given by g of s like this. Find the initial value. So initial means what? By using initial value theorem. I can get the solution by initial value theorem. Why it is initial value theorem? Only because he wants initial value, that is when the instant of switching. That is, what is the initial value theorem formula? Limit, initial means what? T tends to 0, f of t, which is equals to limit s tends to infinite s into f of s. Now here I am providing the solution with respect to frequency domain. Okay, initial value should be equals to s into f of s. But limit s tends to infinite s into f of s, which is equals to limit s tends to infinite s into f of s is what? S plus 1 by s into s plus 2. From this s gets cancelled. Therefore what we have? Limit s tends to infinite s plus 1 by s plus 2. From this limit s tends to infinite s into f of s, which is equals to limit s tends to infinite, I can common 1 plus 1 by s by s into 1 plus 2 by s. S gets cancelled. Then now we have to apply s tends to infinite, should be equals to what? Which is equals to 1 plus 1 by infinite by 1 plus 2 by infinite. Therefore initial value should be equals to what? 1 by 1, which is equals to 1. The initial value should be equals to what? 1. If you have any doubt, go through that time domain approach. Then you have to verify this answer by using time domain approach. Simply we can do the analysis to get inverse Laplace is nothing but partial fraction method. See, partial fraction is nothing but what? Take the given function. From that function you have to extract the maximum fractions. So from this given function what we have? So numerator part is as it is, there is no manipulation in that, but you have to manipulate the denominator part into fractions. That is p, it should be converted into what? S into s plus 2 into s plus 1. Therefore we can do the fractions from this. P by s, like that some constant by s plus 2, like that some constant by s plus 1. To get the value of p, simply we don't have the value of s in this equation. Simply we don't have the value of s. When s is equals to 0, we can get the value of p. Like that, to get the value of 2 when s is equals to minus 2, and in addition with that we don't have the representation of s plus 2 in the equation. That's why see, s square plus 3s plus 1 by s into s plus 1. Like that, to get the value of r, we don't have the value of s plus 1 in this equation, but we have to get the value of r when s is equals to minus 1. So this is the analysis of partial fraction method. From this we are having f of t. So to get the value of initial as well as final value, we can use this theorem. You can verify this answer by using time domain approach or frequency domain approach. You can calculate the initial value or final value by using either method, whether it is time domain method or frequency domain method. This is the pure concept of initial and final value theorem as well as partial fraction method to get inverse Laplace transformation. That's it.